Hello, my name is Pavel. In the previous tutorial I showed you how to install the package for multivariate statistical analysis. Today we will do the simplest principal component analysis of the simulated ILS example, which you hopefully downloaded from the same source, temDM.com. Okay, we go to Digital Micrograph and open this example, ILS cube. It's 100 by 100 pixels and 2000 energy channels. There are three elements inside this spectrum image: magnesium, aluminum and oxygen. You know, in principle there are software to extract chemical maps from such spectrum images, but that's not topic for today. Because of that I will just open the chemical maps which I prepared in advance. Aluminum, oxygen, magnesium. Well, you see oxygen map, quite noisy magnesium map, and in aluminum map you see basically nothing. That's because the original spectrum image was extremely noisy. Our target for today is to denoise it with principal component analysis. Okay, let's minimize these noisy chemical maps. Go to temDM, MSA, and proceed PCA. Here you have tool for PCA. There are a lot of buttons and you normally proceed in the direction from top to down. First of all, you have to create what I call matrix. There is one option to choose. You can choose to build this matrix weighted or not. And if weighted, you can choose weighted on all coordinates or on energy coordinate only. Well, it's long to explain why you need to do weighting before PCA analysis. Just for the moment take on trust that for such ILS spectrum imaging, weighting is strictly necessary. And that is default. Just don't change it. Click at your spectrum image, then press Make Matrix. Some spectrum appears, change scale and view at the spectrum. That's average spectrum. Spectrum averaged over all available pixels. Here we can choose the energy range to treat, or if we prefer to treat all available energy range, just press cancel. That's exactly what we choose right now. We don't need average spectrum anymore. Just close it, not safe. Conversion to matrix is in progress. Now it's waiting. Here we are. That is our matrix. It is named like original data cube, but MSA letters are added. It looks not as large, only 100 by 100 pixels. In fact, it's so-called average image, that is image averaged over all energy channels. But energy specific information is actually not lost. It's attached to this image in the hidden form, the form convenient for further multivariate statistical analysis. And the first analysis we will do with this matrix would be extraction of principal components. Before starting, check the option center. The meaning is the average spectrum will be subtracted from your dataset before PCA treatment. It's default option and I highly recommend you to do that, but in principle you can also try the uncentered PCA treatment. Then choose the number of components you are going to extract. The minimum number is 2, and for the demonstration purpose we will start with extracting of 2 components. Press PCA. PCA is starting, so you can see the status in this information bar and also in the output window. For the moment it's some preparation, but right now component number 1 is extracted. Now it's extraction of component 2. It might take longer. Here we see. Right now program start to display the few selected results of PCA. That is so-called scatter plot of first and two components, and that is loadings. It means spectra of components. Loading of the first component and loading of the second component. Well, also script load, but not very informative in that case, only two components. Well, this data, we look at that and we don't need to save it, just close that without saving. Now let's extract more components. Let's say 5 components. Press PCA and system asks us, 2 components already extracted. Do we want to override that? We press cancel. Do we want to keep old components but add the new one? That's exactly what we want. Press OK. Well, again, you can see the status in this information bar. Right now it's some preparation. Now component number 3 is going to be extracted. Note that component 1 and 2 are skipped because they are already extracted. Well, extraction of more component would take time. In the meantime, I will tell you something about the number of components. In this specific simulated spectrum image, I know there are 2 meaningful components. It's relatively simple object. In practical case, usually we face with bigger number of components. In my practice, it's something between 5 and 10. The important point is you need to extract much more components than you expect to be meaningful, to be real, because you really need to reach noise level and to ensure that you reach noise level. So let's say if you have, or if you expect 5 meaningful components, extract at least 10 components. And if your number of components is expected to be 10, then extract something like 25 components, I would say. Well, but for this example, we have 2 meaningful components and we extract 5 components in total. So right now it's extraction of component number 5. Here in the output window you can see the time required for extraction of each component. It's about 40 seconds for the noise component. Paradoxically, extraction of meaningful component is going a little bit faster than extraction of noise component. That's because noise is really uniform and system really has problem to find the optimal direction. Well, now it's finished, and again system displays you some selected results of PCA. That scatter plot of first and second component, we already saw it. We can close it without saving. And here is loadings. Now there are 5 loadings. Let's check again spectrum of component number 1. It's unchanged. Spectrum of loading of component number 2. It's again the same. And now component number 3. You see that spectrum of this component is pure noise. And the same is true for component 4 and component 5. So we really reach the noise level. close it without saving. Here is our script load. You see that for component 1 and 2 we have big variance, and it decreases first quite quickly, and then starting component 4 it's almost no change in variance. It's more or less constant. Then we are sure that we do reach the component, the noise level. Close it without saving. Well, maybe you already recognize one nice feature of this package. You don't need to store a number of pictures, a number of spectra. You just quickly look at, for instance, loadings, and then close it without saving. Nothing is lost because all information collected up to this moment is kept inside this object, which I call metrics. But of course, don't forget to store your metrics at the end of your session. Well, in the next tutorial I will show you in details how to extract all information from this metrics and display it at any moment. Well, this feature is very different from the other software packages for multivariate statistical analysis. Typically, they would create for each your dataset individual folder, and inside this folder you will find 10, 20 or 100 files, and very quickly you will be overwhelmed with this huge number of files. So we have extracted 5 components and realized that only 2 of them represent some meaningful variations. Then we can reconstruct the original data cube with using only these 2 meaningful components while ignoring numerous noise components. Just check the number of components for reconstruction, click metrics and press reconstruct. The system would prompt you to confirm the list of components to reconstruct. Just press OK and the reconstruction starts. As usual, in the information bar we see the status of process. Right now it's waiting. Also you see the same information in output window. Right now it conversion to 3-dimensional cube from 2-dimensional matrix. It also takes time. Well, reconstruction is finished. Here is our reconstructed data cube. We can quickly evaluate what is changed in spectral information. Just click at the original data cube and at the reconstructed one. Go to temDM MSA Twin View Spectrum. You see that some green pointer appears in both dataset. You can move it and it moves synchronously in both data cubes. And in that window we see 2 spectra. One is filled, it's original spectrum, and another is red line, it's reconstructed spectrum. We can travel across the dataset and see that everywhere spectra are significantly denoised. To stop this viewing, just close without saving this spectrum window. Now let's look at chemical maps. You remember there were some maps from the original dataset. Let's look at them again. Oxygen, magnesium and aluminum. Now we want to extract the same map from the new dataset. For that I have a small script, extract ILMS maps, put reconstructed dataset in front and run this script. You know, there is a standard GATAN ILS quantification package but unfortunately I don't have it installed in this computer, so I have to use my own resources. You see, I designed this command, calculate and show map. That is for oxygen. Here is oxygen offset, width of oxygen signal, and width of extrapolation window before oxygen offset. And I have that for all three elements: oxygen, magnesium and aluminum. It works basically the same as get-on package, but a bit slower, so we have to wait. Here we are. So to see it better, we close all these windows, and now let's compare. Aluminum, it was like that, actually nothing, and now a new aluminum map. Magnesium, it was, and now it is like that. And oxygen map is also quite improved. So you see that we did a great job. We denoised our spectrum image quite significantly. Before finishing today's session, I remind you to store this matrix, because there are a lot of information in this file, and in the next tutorial I will show you how to extract this information, display it, and also how to compress this MSA matrix.